what is the mapping robot dog? Well, the robot dog is our Ghost Robotics flagship robot, also known as a quadrupedal unmanned ground vehicle. The Vision 60 is the platform that we put the Void scanner on. That was our current version 4 robot, and soon to be replaced by the final build here in December of the version 5. So traditionally, we've been rebuilding the platform, improving on it every 3 months, uh, integrating in customer feedback and trying to enhance the platform, really getting it out into the customer's hands and beating it up to see what works and what doesn't work. And through that kind of rapid prototyping, we've kind of wound up with the platform that we have today, and ultimately the platform that we'll have tomorrow, the version 5 here in December. Completely IP68, really meant for these tough, rugged, harsh, nasty environments where people actually want to send robots, specifically ones with the types of capabilities that we've got integrated into the platform itself. Vision 60 is a platform. I like to think of it as a walking server. However, it's a mobility platform that's got the kind of fidelity of life baked into it, using the control platform that provides kind of the reptilian brain and these reflexes. So that matched with the high level autonomy stack really provides a compelling platform, a compelling mobility platform to help move sensors, payloads, communications, data through the physical world, and do so, either ad hoc through a remote control station, or in some instances, fully autonomous. So, that's step one: is let's move things around the environment, get something from A to B, really no matter what, and in whatever condition that the environment may be throwing at the dog. The mapping component is the augmentation of the dog, adding a various type of sensors. So in this case was the Void scanner, which allows us to automate the process of mapping kind of an underground or subterraneous environment using the Void scanner's capability out of the box.
In addition to that, for the mining activity, historically, we've had different types of robots, around for 10 years now, and the mining looked at those very early on, but they were all either tracked or wheeled. Very few were the quadrupeds, like the Ghost robot, and the mining companies are now seeing that finally they have a sensor carrier that can come into a mine that has rubble, has other difficulties, and using the legs and the hopping and everything else that the Ghost can do, it can be a solution set for the miner that they've not had before.
Yeah, and I guess to kind of carry that thread a little bit longer, right? There's a reason when you look outside you don't see robots, and that reason is because it's challenging, but more importantly, there just hasn't been a platform that can live, breathe, and exist in the elements day in and day out. There are plenty of, hobby or kind of PhD robots that you've seen. But when it comes to these types of environments, or just being outside, like your car is a pretty tried and true tested piece of equipment, right? It's pretty rugged. And now you have to take that and complexity, and actually arguably even more complexity, and shrink it down into as small of a package as possible, and then make it drive itself, right? That's what field robotics is all about. And so it's challenging, it's very exciting, but because we just haven't yet have had a platform to put things on, that's one of the reasons we don't have robots running around. And that's what Ghost Robotics is. That's what we're trying to change here, is that we've built the platform that you can go to, add your sensors, your meshes, your lidars, your sensors, and put them out into the environment and trust and know that they will work and get the job done.
I think for me, right away, some of the applications that I see is kind of building on what we were talking on, with the Ghost robot dog being a sensor platform, is it allows us to kind of safely get into these inaccessible areas that otherwise might be unsafe or unfit for a person to walk into, and it allows us to collect data. In this case, LiDAR data, so a point cloud of some inaccessible area that needs to be mapped. So I mean, right off the bat, one of the applications or areas that jumps out at us is the mining industry. You know, where you are working underground, in and around old workings or new workings that have just been blasted out, and you don't know what shape or size the cavity might be. So having access to something like the Ghost Robotics dog with a void scanner on it, it allows you to deploy the scanner into that area and create these nice 3D shapes, that can then be used down the road by other engineers and planners in their daily mining activities. And to me, that's kind of like an immediate application where I can see this being a really good fit for this partnership.
Yeah, I'd say the subterraneous environment has come up again and again, and it's really, I will say you don't have to necessarily be underground to be in a subterranean environment. And that's that air quotes happening right now. That's because really what you want to say is you're in either like a GPS denied environment. That's another term that's used, but the challenges that are in a subterraneous environment, take this with a grain of salt, is really, even large indoor spaces. And that's if you don't have, obviously the lack of communications equipment and stuff. But in terms of, where that void scanner can add value is anytime where you're actually just trying to produce a 3D volumetric scan of an entity, which could be deep underground or be a building or under a bridge or a pipe or some other type of structure where you're interested in understanding what the 3D volume of that space looks like. Yeah, we put together an application with a thermal camera.
Yeah.
And thermal camera mounted to the front of it, just on the robot. We wrote a little computer vision algorithm that basically looked at the change in intensity of the pixels near the mouth and nose region, and then kind of assessed the frequency, and then kind of monitored that for a little while, collect enough data samples to either say, "Yep, that person is breathing," or "No, that person is not breathing." So it wasn't necessarily one killer sensor that did the whole thing, but this is what happens when you take all of the types of different sensing modalities that are available. All these sensors are getting smaller. The thermal camera that I mentioned is probably the size of like a 5 quarters stacked together, so it's itty bitty. And all of the types of sensors are getting so tiny. So putting them on the robot to be this environmental sensor, that's measuring volatile gases and other sorts of hazards, is not far fetched. It really can become, we're going to be talking about the mapping robot dog, but it's really the robot canary that is the killer application perhaps for the mining industry. Is you've got something that's able to produce 3D maps, sense the environment, whether it's gases and other types of things that you don't want, but also be able to observe perhaps the workers in a passive way, maybe looks at something about them to ensure that they're doing something safe, or if someone's sitting on the ground for whatever reason, robot can go up and perhaps check some vitals or do something like that. Well, I would say the mine company themselves. I don't know much about the cost structure of what it takes to, actually bore a hole, send people down in the hole, and then pull out the ore. But I imagine it's not very cheap, and certainly there's a lot of insurance costs. Um, the conversations that we had when the Carlson folks were here was just the scenario of you blast a hole in the ground, or you're underground and you blast some rocks away, and now you need to see how much rock you blew up. And in order to do that, you've got to send the void scanner in. And in order to do that, you got to wait a little while. And you got to wait a little while because you're not sure if there's loose rock that could fall and crush you. And so then you put it on one of your big pieces of machinery that's capable to extend a boom out long enough. And so the act of doing that means you're now not able to use your piece of machinery for its primary use case. So that's down. Finally, you get the scan. And so essentially you get this like compounding effect of just like delays. But here, when you've got a system that can arguably is cheap relative to your larger equipment, you need to go in, get some information quickly, get it out. Uh, those who are interested in that data and that time efficiency, those are the people who are going to benefit from this technology. Yeah, I mean, all of the above. It unfortunately didn't snow last year very much. So, I mean, snow is cold is a little easier to handle. In terms of high heat, we were just in Nevada for 10 days for an Air Force exercise. We had the robots up every day running. I don't know. Some days it hit 115 in the shade, and so these robots are out on the flight line, walking back and forth every day. I mean, they got hot to the touch. You didn't want to touch them because they became so hot, but they're still running. So in terms of thermals, I think we're sitting pretty good. Those are kind of the biggest worries, but we've been very. That's been a key. Um, what's the word? Like attribute that we want to make sure that the robot's capable of operating in is high heat. So up to 65 Celsius and down to minus 40 Celsius operating environment temperatures.
Yeah, I think what kind of sets the void scanner plus apart from some of the competition and the units that it competes directly against is how simple it is to use. It's simple, it's quick. It integrates really nicely with the Carlson scan software to create these easy to use and easy to manipulate point sets and data clouds. That can be then turned into a surface and exported into whatever third party mining or mine planning package you might be using. The actual hardware itself is extremely rugged, reliable. It's been tested in harsh underground, wet, rough conditions for over 15 years now. When looking at the Void Scanner Plus and I guess kind of its evolvement over the years, one of the parts that one of the features that's quite I guess nice about it right now, or a selling feature, is the fact that the new Void Scanner Plus has the built-in battery and the built-in wireless unit. So you're actually running a cordless setup from the scanner itself back to the end user who's running it all and controlling the scanner from a tablet. So again, it's really quick to set up. It's easy to get started. And within a matter of minutes, you have this beautiful colored 3D visual of this inaccessible area or the space that you're trying to scan. I think originally the scanner itself was designed to be used in underground environments where underground mines, typically hard rock mines, where they're doing long hole stoping. But because of the versatility and the simple operation of the actual unit itself, it's kind of opened up some other areas where the scanner is being used, other types of underground minings, and then it's even kind of moved into the surface operations, whether it's scanning in an open pit, a new active face. It can be set up on a tripod, or again into containment areas or storage facilities, where a mine site or a quarry might be creating stockpiles. And so it could be used for inventory purposes, for creating I guess a 3D scan or a point cloud and some volumetric data of the different stockpiles in a quarry. And I think, again, that's where that tie-in with the Ghost Robotics dog is kind of nice, because it kind of turns it into a mobile scanning device, and it can move throughout the open pit mine, collect data close to dangerous faces where they have been doing blasts, or it can get in around behind the back of piles. Again, kind of collecting data and providing information in these hard to reach areas.
I mean, it can travel. The dog can be programmed in such a way that it doesn't need persistent communication to the control station. So you could say, I know I'm going to probably lose comms, but I still want it to do the job. And you program the robot and get it to tell it to continue when it loses comms, and then let it wander into the environment and come back. So it's actually all designed. You don't have to really do anything. It's meant and designed to lose comms. In robotics, you're going to lose comms all the time. And so when you load up missions to the robot, it's actually got everything it needs to be completely self-sufficient. As an operator, what you're just doing is just kind of monitoring the robot, and got your hand on a safety switch if you need to do something, or if there's something that you see is interesting that you would want to modify the route. But once you load a mission and you push go, that's all you need to do. Yeah, so lots of different ways. The obvious is for the outdoors, use GPS when you got it. It's such a good sensor. For the underground scenarios, you can still leverage some GPS. Let's say you're going into a tunnel for the first time, right? So you want to be able to uh, register the map that you've been collecting or about to collect with some sort of geospatial data. So you've got those points prior to going under. But then equipped with the robot itself are its own navigation sensors, as well as algorithms to use that data to provide GPS denied odometry. And so we use everything from the vision sensors, the time of flight sensors, as well as some of the information from the kinematics of the legs to be able to provide a estimate in position over time. Now, things that we could do in a more long-term installment would be something like setting up fiducials, whether those be visible for cameras, or maybe they're high-vis prisms for laser scanners. All of those things could also be kind of put to use to help ensure that the robot is able to, especially when it just turns on, to register to its surrounding environment and know where it is, so that as it proceeds through the environment, it's able to say, hey, I've actually moved this far from this said location. So we kind of provide these tools and these algorithms as part of the robot's competency and capability that allows it to be this tool where various customers can add their own sensors and applications onto it and not have to worry about those types of things.
as mines, especially surface mines, get to be more and more automated with the trucks running. And as you know, the mines that are running automated trucks now, part of their safety aspect is that when those trucks are running in a certain grid area, there are no humans allowed in that area. And we all know that there's some minor things that need to be done, that they have to be walked over to, a button has to be pushed, et cetera, that if there was a mobile robot that could fill in and could walk around amongst the trucks that are moving and excavators or whatever else is down there that's automated, that would keep that person that by doctrine is not allowed to be down there, and would keep from shutting down the mine site to get a human in there to do whatever minor little activity needed to be done. The Vision 60, the Ghost, is perfect for that type of operation.
Yeah, and what you could do is, as you mentioned, people aren't allowed in there when you've got all that big machinery operating. Is another use case, since we do our new version robot, the version 5, is going to have 360 visible cameras on it. You could use it as a telepresence style robot. So you physically may not be able to get there, but we can certainly create a pretty immersive session with the robot and have it be controlled from some common interface station somewhere else in the world. So we were just doing a 5G pilot in New York just the other day, actually Thursday and Friday, with the robot, and we had folks controlling the robot, driving it around the facility, and here back at the office in Philadelphia. And then we also had folks in California driving the robot around with zero issues. Right, so that's something that with the right comms infrastructure, you could have your CEOs, or I don't know, the mine managers, if you will. They could be in a completely different country probably, and be able to personally walk the site on one of these open pit mines, and give things a thumbs up and thumbs down without having to get into an airplane, which might become very prevalent, given the current climate with the virus and everything.
Yeah, we both kind of have our strengths that we bring to the table. With Ghost Robotics being a platform or an interface for collecting data, and Carlson working with sensors, it kind of seems like a natural fit. A way to kind of to mobilize some of these different tools and sensors that we design and engineer. Yeah, and so to me it seems like a good fit.
Say maybe not take over, but certainly allow you to put your feet up and relax a little bit more. I think it'll be
essentially Skynet. That's good.
it'll be a little while, I think, before that happens, but it will certainly allow us to better spend our resources and time. Not doing mundane tasks, and certainly the dangerous tasks, and letting robots do those is important, right? Automation is the key in today's market for cutting costs, as well as providing quality control. If you can't automate it, you're going to have a hard time for quality control, and that's very prevalent in just about every market. Especially when you've got people walking around with handheld sensors, you could get different measurements depending on who's doing it. Maybe the person they might even just walk the walk, but maybe didn't actually take any measurements because they didn't want to. Maybe they had a bad day, they wanted to get out of there, they didn't do it at all. So we hear these stories all the time from, what's wrong with doing the current method with, people carrying around sensors or something. Now, granted, here with the void scan, it's a little bit dangerous. You can't do that, but um, some applications where it's just like, let's take photographs of certain areas every day or every week to analyze the change detection, if you will. You can only do good change detection if you've got good quality data, garbage in, garbage out, and that's very much true for kind of running any sort of automated analytics on change detection, which is a very powerful metric on whether you're measuring the stockpiles of materials, or how deep a hole. I'm sure you guys know how to do all of that, or various mining companies can do that, but automation is the key. But I wouldn't think that the robots are going to be able to do anything much more beyond that anytime soon.
There used to be an old term. It was called management by walking around. And that's where especially the CEOs, the VPs would get out of their office and they would walk through the office space, or they walk through the factory, or make it down to a mine, and they could get in touch with what was going on. Now you can imagine in the international community right now in mining that I know that there's VPs and CEOs out there that have never ever put their college shoes in the mines, in certain mines, dirt. After they got the job, they're looking, they're looking at their finance, etc. Just another tool in that aspect of getting the upper echelon back in touch with what they're managing, and the invaluable insight that they could get for something like the Ghost robot to be out there and to be their eyes and ears so that they can get back in touch. And I think once a CEO uses this or uses it as one of its tools, not to use that totally for that, but as one of the tools, it'll be something that a lot of them will be demanding to have.